Hello, everyone. Today's session is all about handling PII securely in modern development workflows. As teams increasingly rely on short-lived, on-demand environments for staging, testing, and fast releases, one challenge stands out. How do you quickly get access to an anonymized data set that mirrors production without risking exposure? That's where today's focus comes in. Bunnyshell takes care of creating and managing ephemeral environments. Zeta ensures the data inside them is safe by anonymizing it in a way that preserves structure and behavior. So let's get into the details. I'm going to hand it over to Alex Francoeur. Alex, stage is yours.
Oh, thank you so much. All right, well, I'll jump right in. These are the presenters that will be participating in the discussion today. Can you guys hear me? Just want to make sure. Okay.
Yes, we can.
See the green button. Perfect. These are the presenters today. Tudor, myself, Alex, and Amin. We'll be doing a bit of a presentation, some demo, and then some discussion at the end. As far as housekeeping goes, just here's some quick things. Make sure your volume is not muted so you can hear us, because I'm coming through apparently. Make sure to refresh if you're seeing a little bit of lag. Ask some questions in the Q&A section. We'll answer any of the questions towards the end of the webinar. And then make sure you just say hi to us in chat, and we'll be sure to send a recording whenever this is over, so you can share with your friends. And so ephemeral environments are generally one of the best practices for developing applications that have PII and sensitive data. I'd argue it's probably even more important now with AI and vibe coding these days. One of the most important pieces of the puzzle is your database. So having a realistic production-like data in your staging, testing, and development environments is really a force multiplier throughout the entire development process. And so when you have a data set that is representative of your production environment during development, you get a number of different benefits. You have significantly fewer surprises in your deployments. Synthetic data typically does fail to represent real-world edge use cases, and having a production-like database allows you to catch those bugs significantly earlier in the development process. You get much more confidence in your changes that they haven't impacted performance in any way. Bottlenecks typically don't show up in small, clean data sets. You polish your production user and development experiences. You don't have to anticipate things like long names or paginations in some of your user workflows. CI/CD pipelines that actually do reflect user behavior. So you can test fixes, so you can automate tests that typically pass on synthetic data, but usually fail in production conditions. So having a realistic scenario there helps a lot. You have easier error reproduction. Testing fixes become much faster when testing against real-world scenarios. Safer rollout and rollback plans. Individual teams can do dry runs. They can validate migrations earlier. They can test new features with higher fidelity. And then you get more robust incident detection as well. You can test things like alert sensitivity and threshold with production-like volume as you develop the new features. And so these are just some of the many benefits of having a representative data set that mirrors production. Sign me up, right? It sounds wonderful. Wrong. I mean, yes, definitely sign me up, but it's just not as easy as it sounds. So going down this route definitely has benefits, but it's difficult to balance. This is a somewhat recent example of a data breach from a known observability company, New Relic, where a bad actor was able to actually gain access to their staging environment and access real customer data. And so these types of incidents aren't just frustrating for the team, but they can actually cost companies hundreds of millions of dollars. So why is this so hard? Over the last year, I've spoken to many CTOs, VPs of engineering, platform engineers about this problem. And there are some of these challenges that I've come across. There's definitely a balance between data fidelity and risk of leaking sensitive data. It's a risk-reward scenario, and you really need to put time and effort into making sure your sensitive data is masked appropriately. Keeping schemas and data in sync in multiple environments is typically a nightmare. I think we even have a number of blog posts about this, but it's pretty time-consuming. And if you get it wrong, out-of-date environments can introduce false positives in both quality and performance. Compliance these days is also increasingly important to every business. Every piece of PII leaked is a breach of GDPR, HIPAA, and SOC 2 standards. Maintaining large test environments can be pretty expensive, especially in distributed systems. At a certain scale, it may not be worth the benefits and strategies like subsettings will come into play. Data masking logic can be super complex and difficult to get right. So things like intelligent obfuscation is required to keep the shape of the data while still removing PII. And if you've ever had a bug fix that worked on your environment but not in staging, It's likely due to some sort of environment drift, and this extends beyond database, but bugs can go undetected in your development environment because it doesn't represent production appropriately. And so these are just some of the challenges that I've come across personally when speaking with people. But the solution typically ends up resulting in two different strategies, I'd say, that address most of these challenges. The first is anonymization and data masking. This is probably the most important part of the use case. You need to implement with deterministic transformers to keep the relationships in your database. When schema changes occur, you should be more conservative than anything, either generating errors that stop your pipeline or default to obfuscating data so you don't have any data leak. And then the solution shouldn't have any impact to your production database in any way. You want to make sure that it's completely decoupled. And subsetting also becomes more important as you scale and becomes particularly difficult in distributed systems. You'll need a solution that keeps the same shapes and relationships as production and provides control over the volume of data depending on the use case. And we'll be diving into both of these strategies today during the demo. Now, I work for a company called Zeta, as I mentioned, and we've dedicated our entire company behind this mantra: don't fear database changes. A database is typically the most critical piece of your infrastructure, and we generally want to make sure that our customers are confident when rolling out optimizations and changes to their database. And so we have a few open source Postgres tools that we've created our entire platform on. So it's built on top of this, and we have different use cases we're supporting, but they're standalone tools as well. PG-Roll enables zero downtime, instantly reversible schema changes. PG-Stream is a change data capture tool that offers Postgres replication and transformation support with DDL changes. And our agent is the latest tool that monitors your database, does root cause analysis, and recommends optimizations. Each one of these tools is interesting in their own way, and I'd encourage you to check out their GitHub repos if you're interested. But I want to bring that up because we'll be diving into some of these today. We've recently built a solution that we'll be showcasing, specifically geared towards providing realistic staging and development Postgres instances. And so the idea is pretty simple, but it unlocks a much faster and confident development workflow when paired with ephemeral environments. So in theory, your production environment can sit anywhere. And within that environment, you configure anonymization and obfuscation rules on the columns with sensitive data. The latest data can then be pulled into a scheduled interval from a backup or snapshot, or you can stream the data in near real time. And this results in an up-to-date staging replica with all of your PII and sensitive data removed, and adds a new tool to your team's tool belt, which is essentially database branching, kind of like get branching, but with your database. And with a replica, with a staging replica available, you can instantly branch your database with every feature or bug fix with just simply within a pull request, making it super simple to have a realistic production database with every PR without sensitive information exposed. And once your changes are complete, we provide tools to merge back to production without any downtime and revert instantly if there was an error. And we'll be rolling this out into private beta pretty soon, so you can join our waitlist if you're interested. There's a URL at the bottom of the slide here. But the important aspect for this webinar is the anonymization and PII removal piece. For this, we use our open source tool that's built for Postgres called PG-Stream. PG-Stream is built specifically for this use case and has benefits over other tools by being solely focused on Postgres. These are some of the features it supports, and we'll be diving much deeper in the next slide and within the demo. In the architecture side, PG-Stream is constructed as a streaming pipeline. Starting with Postgres, data moves from one module to the next. It is accessible as both a CLI and a library. And unlike other tools in the space, it keeps track of schema changes and replicates them along with data changes to ensure a consistent view downstream. The implementation relies heavily on Postgres write-ahead logs, or WAL, splitting into WAL listeners and WAL processors. And so a listener listens to WAL events regardless of source. It consumes the events and delegates processing them. Today, PG-Stream supports Postgres listener that listens to the database directly, a Postgres snapshotter that produces events by performing a snapshot of Postgres, and a Kafka reader that allows PG-Stream to scale by reading WAL events from the Kafka topic. On the other side, the processor processes a WAL event. There's a Kafka batch writer that writes WAL events to a Kafka topic and can fan out sequential events. There's a search batch indexer that indexes data to OpenSearch and Elasticsearch, a webhook notifier to send notifications to any webhook endpoint, and then there's a Postgres batch writer that writes to another Postgres instance, and this is where we'll be spending our time today. So in between the listeners and processors, we've recently introduced transformers. Transformers can technically modify the data in any way, but for the purposes of this use case, we focus on anonymization and obfuscation. They're easily configured as part of a pgstream config, and you simply need to paint a rules or just point to a rules YAML file. And we just released a blog post today with some tutorials if you'd like to read up and learn more about the workflow in pgstream. I have a link at the bottom of the slide there. So I'm not going to go into too much detail here, and I'm sure you're sick of listening to me, but we're going to walk through a lot more detail in this demo. And so just as a quick introduction, I'll provide a few quick examples of what some of these transformers look like for anonymization. And so in this example, a first name transformer takes a few configuration parameters, a generator and a gender. The generator is set to random, it will provide any value. When it's set to deterministic, it'll persist the relationships. And you can take into account gender during the anonymization if it impacts your app, for instance. These are there's some example inputs and outputs here, but this is a super simple transformer. And then there are more complex ones like email, where business logic is typically applied within the application. So you can do things like preserve length, the domains, define actions, and take on invalid emails as part of the pipeline. And this is easily defined again in like a simple YAML file. In general, there are simple transformers, more complex ones, and then really complex ones that require deeper understanding of your database and schema. And we plan to continue to build out pgstream's transformer library over time to support both common anonymization rules as well as custom ones. And so I hope you enjoyed the quick introduction to the general problem space and Zeta and the types of problems we're trying to solve. But I think it's time to get to the meat of it. And I'll pass the mic to Tudor to give a demo that brings production-like data and ephemeral environments together with Zeta and Bunnyshell. Tudor, I'll stop sharing my screen. You can take over.
Yep. Let's do this. All right. Hi, everyone. So I'm going to show you a demo to see all the concepts that Alex has spoken about. And this demo will include Bunnyshell and it will include Zeta. It will include AWS as well. So let me start first from like a whiteboard diagram to understand kind of what the setup is and how we're going to change it. So what we have is a production database. This is all pretend application, but it's a production database in using simply RDS. It's this one here. It's just a normal RDS instance, and then we have a Next.js app. And for this production, we're going to say that we run it on Bunnyshell. From what I understand from Alex, you can run your production in Bunnyshell, and I think you can. I don't know, Alex, if you want to say how that works, but I imagine you can give it your own your node domain and so on, right?
Let's return to the question after the demo, but everyone should know, yeah, Bunnyshell supports production. So
right.
Back to you.
Yeah, so you can, like in many setups, you do something like this, right? Your production is fully in AWS, let's say, but you can also do it like this if you want. You can actually run Postgres in Bunnyshell as well, but of course, then it wouldn't be RDS. It would be just run on Kubernetes. This also works, so you can run, you can run production database in the Zeta platform and Next.js in Bunnyshell, or any combination of there's a lot of flexibility there. But this is what we're doing in the demo. So it's AWS production here, and then we're going to create ephemeral environments using Bunnyshell and Zeta together. The Next.js app is a simple app that I created. It does this kind of a dashboard page, and in the database, so in this RDS instance, I have loaded the Northwind database. It's a very common data set that's being used. It has these tables. It's kind of like it's like a e-commerce type of data set. And in particular, we're going to look at the customers table. RDS doesn't have a nice way to visualize this data, so I'm going to with PSQL. These are the table. These are the columns in that table, and these are the columns that we're going to anonymize, right? Because we don't want we basically, when we copy when we copy the data from RDS to staging, from pro to staging, we want to have this anonymization step in between, and this is going to be done with pgstream. pgstream is our open source tool. It's a little bit like a Swiss Army knife that does all sorts of replication. It can do from Postgres to Elasticsearch or OpenSearch. It can also do Postgres to Postgres. It actually had a release today. And we have recently added the functionality of transformers that do anonymization. So let's see that working. The configuration looks something like this. There's this, transformers YAML file. And here is how you configure the transformers. First of all, we're going to work on the customers table from schema public, and we're going to apply these transformers to the columns. The contact name, we're going to use these transformers called GridMask first name. GridMask is an open source project, another open source project that's dedicated for anonymization and has all sorts of transformers. What we did in pgstream is we are able to use transformers from GridMask. Transformers from Neosync is another open source tool that can be used, as well as our own transformers done in pgstream. So you just again have a lot of flexibility. And then the phone column is modified with a transformer that is supported by us. It's called phone number. And what it will do, it will replace them with a particular made-up number, right? And I set the prefix 555 so that we will know that, okay, this data is now anonymized because it starts with 555, right? Then for the address, I wanted to show the choice address, choice transformer, which means it will take randomly one of these choices. Now, what's interesting with these transformers, you can make them purely random, which means that it will take a different random value every time it will run, or you can make them deterministic. If you make them deterministic, it's still random, but it guarantees that every time you run with the same input, you get the same output all the time. This is especially useful in relational databases when the data might be relational and relate one with each other. So being deterministic can be important. Then for region, I'm doing the same GridMask choice transformers. And then for the postal code, even though it's a number in this data set, is represented as string because I don't know, postal codes in different countries have different formats and such. What I'm doing here is generating essentially a number but a string between 5 and 6 character length, right? And this is just a relatively simple example of anonymizations. Now, if we run this, it will be something like this. And this will copy the data. It does this, right? Copies the data from your RDS to the staging database, including the schema, including sequences, triggers, whatever you have, all of that stuff, including the data. It copies it and transforms it as it goes. So now it's done. And if I look into the staging database here, I will see that there's I will see that the schema shows up here, and we get a nice diagram with the schema that we have. And the data is now already anonymized. And I will show that, but in order to show that, I want to start an environment for the staging. So we have the Next.js app here. So I'm just going to start that. This was our production. I'm looking now at Bunnyshell. This was our production environment, and we have the staging one. And I will just click deploy. What will happen now? I will explain it while it's happening. First of all, the Next.js app will be deployed again. And here in Zeta, a copy on write branching will be created. And this is actually the main reason you would do this in Zeta. Now, there's more reasons like also cost and so on. But one reason is that you get now this copy on write branching, which means that you get instant branches, no matter how, how big your database is. You get a copy of it. It looks like a copy of it instantly in another branch. So you can easily test things. This is like what the power of it is, if you want. And this, like this would be connected with this one. Now it would also be possible to do it without a branch. So have an environment that does something like this, connected directly here. But anyway, in my case, I did it like this. So even for the staging environment, there is a branch created. The advantage of that is that when we create ephemeral environments, they will use this data as a data here, not this data here, in case there are modifications. So this is our staging environment now. And let's give it a name for clarity. And this is a Bunnyshell environment. But you see how the Next.js app is running in Bunnyshell, in the Kubernetes cluster from Bunnyshell, and the branch, the database branch from that environment, it's running in Zeta. That's being done by using this connector. It's kind of an integration between the two products. If just briefly, let's look at the configuration of it. So the Zeta database, this is actually starting it in Zeta and uses this deploy commands and destroy commands from the integration if you want, and it will export the connection string and the branch ID and takes some things like the API token of Zeta and so on, and it will export. As I was saying, it will export the connection string. That's the main one that we need. Then in the Next.js app that's being deployed, the connection string is used like this. You see components, database exported, connection string. So this makes essentially this connection between them, right? By now, I think it should be done. So if we look here at branches, you see it. This was created by Bunnyshell. There's as I said, a copy or write branch of it. And if I go here, I'm in staging and open the URL, you see the application running. And you will also see, if you compare to the production one, that it's now anonymized. How we know? A few hints, like the phone number. As I said the prefix 555. That means this is mock data now, and you see all of them are with 555. And wherever, I don't see it now, but wherever there's null in the database, in the initial database, it will be null also after anonymization. So it keeps that information. Or you can do it another way. There are multiple ways. And now, like if I open this one, you can see the data anonymized. Also, the address is one of those choices there. So there's no private information now, which means that you can give this access to your developers, which is, of course, important for privacy. It's also important. So, for example, if you have emails or things like this, you don't want your staging system to accidentally email our customers and situations like this. So it also helps with that. Right. Now, so we did a staging environment. You saw the data anonymized. Let's mark it here. In this demo, I only did anonymized, but you could also do subsetting at the same time. So subsetting is important, even though this copy on write branching is instant, as I said, or very fast, regardless of how large your database is. It could be terabytes, and you'd still get the branch almost instantly. However, if you have in production, like let's say 20 terabytes of data, it's just not practical to work with that, and you might not want your developers to work with terabytes and terabytes of data. When like something like 10 gigabytes of it might still be enough to reproduce most issues, and then you can save on cost as well. So that's what subsetting does. Right. Now, what I want to do is add a feature to this app, and the feature is being able to delete some data. Basically, I wanted something to do to mutate the data, and deletion is kind of the simplest way of mutating something. So I'm going to quickly open a PR here, just create a new branch and push it upstream. Why I'm doing this is to show how an ephemeral environment is created automatically, and the data in this ephemeral environment is going to be also anonymized, because it's so you see, like, this has started, and it's happening now in Bunnyshell. We can also see it starting here as the ephemeral environment, and it will again start a database in Zeta. And the database is going to be copied. There will be another copy on write branch from this one, right? It's like copy on write, which means that again it's really fast. And this would be branch 2, let's say. Branch 2, and we get another instance of this one, and the whole thing is an ephemeral environment, right? And you typically do this for each PR because they're cheap and they're fast. Even if with data, the data is already anonymized, so you don't have to worry about that. So you can do it for each PR or whenever required. You can also do it manually. You can start one just from the UI by cloning the dashboard staging one. And you can also do it from the Zeta application. Basically, I can start from here as many branches as I want. So maybe I create like a dev1, and then branches of childs can also have more children. So I will do maybe like a dev2 here. You'll see it comes after under dev1, and I can go this. We can actually go 15 levels deep on this one. I'll do also dev4 maybe. And you see I can create this sort of trees. These are all starting in the background now. So what I did is basically created more of these branches. It's like dev1 here, and then from dev1 I created dev2 and so on, right? And they're all copy on write, which means they copy not only the schema but also the data from them. However, they're one child of another, but they're also independent. So if the data is modified in any of them, it doesn't affect any of the others, right? And whenever you start a new one, it will be from the staging database, which it's kind of resetting it if you want. Let's see where we are with that. This one is probably started by now. Yep, there we go. And this is the feature that PR was adding. It is basically this delete button. And let me delete a few records. So maybe, it's like I delete this one. I deleted all that start with A, and I will delete some of the Bs, just to be obvious. And now if I refresh, the metrics are going to refresh as well. So it was 90 before, and now it's 83. In this ephemeral environment, right? If I look now in production, then of course that's still 90. We wouldn't touch that one. No, this is not production. This is actually staging because it's anonymized, right? This one is production, and of course this one is still the original data 90. This wouldn't be touched. And here you see the data is not anonymized. It's the original data from the Northwind data set. Right. Then like let's say I want to modify the data in dev2 here. Then even if I modify the data in this dev2 database, dev1 is not touched, and also dev3 is not touched. So like they are all decoupled. That's only when the initial snapshot is being done, but then when there are writes that go to each of these instances, then the data is then copied. That's why it's copy on write. Whenever there are writes, the write blocks are copied over, and you get distinct copies. So they have this hierarchy, which can be really useful, but at the same time they're also independent. So maybe like let me show you that actually, and I will do this delete query on dev2. Oh, wait, I'm not on the right one. So I will go on dev2 and run this delete command. I need to run 2 because of the data is relational. So I ran this 2. And now if I do a select on dev2 again, this one is empty, right? Because I just deleted everything in this dev2 branch. However, if I go now to dev1, which is, or let's say dev3, which is a child of dev2, this one should have data. Wait, what did I do? And branches. I don't know what's going on here. Let me show you dev1 then. I should also you see I created quite a lot of branches, so we get this nice figure of it. And now queries, dev1. Yeah, so the data is there, right? This is what I wanted to show. And that's, I would say, pretty much completes the demo, what I wanted to show. So again, just to quickly go over it. So we have our production database. The data there is private. We want developers to move fast and don't get blocked with each other with a single staging setup or something like this. So we want them to have ephemeral environments. At the same time, we don't want them to access private data, and we want them to have enough data so that they discover relevant bugs and so on. That's why we're using this copy on write branching on the Zeta platform. And that's it. And let me know if you have any questions.
Actually, there was one question, Tudor. Let me throw it at you immediately. Sorry, let me check. It was Gabriel Udrescu who asked a question, which was, how do you deal with subsetting for relational data? Example, you have 500 customers, but they have 5 million orders.
Yeah, that's a very interesting question, and we don't support that in pgstream yet. However, it's something that we want to work on. And for example, GreenMask is a open source project that does this. And we're going to like we're working with them, and we'll see how much we use GreenMask directly. We can use it today, or we add this functionality in pgstream. The way it works usually is that you pick up a table from where you start, and then you follow relationships. So foreign keys needs to be defined. So let's say in that example, it was customers and orders or something like this, right? Let's say you configure the tool to take 10% of the customers, and then the tool automatically does the internal joins in the orders table to select only those that are related to it. And that works one way. And then you can also work these relationships back. You could start from the orders table and say, I want that to be sampled to 10%. And then you follow the relationships back. So as long as the foreign keys are correctly defined, the tool can work on that, can work with that information. Of course, it takes more configuration. That's why it's like I think it makes sense when you have really a lot of data in the terabytes and so on. If you don't have that much, actually you could probably take it all of it.
Another question for you, Tudor. How do you make sure you don't accidentally drop the production database?
So you would use different credentials. So like the production one here, it's like has its own password or API keys or whatever used. That's only configured in this production environment. Whenever you get each of these databases in Zeta gets their own password. Like it's in here, but we can reveal it. It doesn't matter too much. I'll destroy this afterwards. So you see, it's a really long generated password, and it's different for each one of them. So if I go to this one and reveal it, it's a different password. So each environment gets their own. That's being passed automatically. Like in this demo, is passed automatically to the Next.js application via the Bunnyshell environments. So you as a developer, you just don't get access to production at all, which is also important for privacy reasons.
If you allow me to add on that, Tudor, other than whatever Zeta is providing you, having different credentials for the databases and everything, if you're using Bunnyshell, you can also have a termination protection on the environment, meaning nothing will be deleted, not accidentally, not in any other way. Everything will be kept safe in that environment that is marked as not for termination. So we have another question here. So how does Bunnyshell do data seeding and migrations for ephemeral environments? Alex, you want to take over that?
Yeah, hey, so depending on where the database lies, there are at least three different scenarios within a Bunnyshell environment. So first of all, the database could be in a container inside the environment. This is something we haven't seen in this demo, but the simplest case, the most dev-like environments would have the database inside the Postgres container running inside the environment. And in this case, the logic for seeding and migration usually is implemented in the container image and some scripts. So for example, Postgres Docker images use the Docker entry point in edb.d folder where any script and SQL dumps mounted over there are automatically executed. And this is how you do the simplest form of seeding and migrations. Now, this kind of has the disadvantage that it's kind of static data. You don't get it from production, and it's not anonymized. So this is where the value of something like Zeta comes in. If you don't have something like this, then you would have to cook your own or maybe do some periodic exports of data into known locations. And then these containers, as they boot up, they download the seeding data and see the database. This is the first scenario. The second scenario would be cloud managed databases. Like in Tudor's scenario, the production is in AWS. So we can imagine scenarios where people want to have staging similar to production, and staging would then have to have its own RDS database and would have to be decoupled. So in Bunnyshell, we handle that through Terraform. So anything that doesn't live inside the environment, but that's a managed solution from outside is created through Terraform. And you can build that on you can deploy manage databases this way on basically any major cloud provider. And once the infrastructure is created through Terraform, then we make use of generic components in Bunnyshell, which are a way to basically script anything. So the generic component would connect to the newly created RDS instance, and if needed, adjust the data over there, or populate or seed, or maybe that might not even be necessary, depending on how anonymized the initial data is. And the third scenario is similar to what Tudor showed, where the data lives in an external serverless provider like Zeta. So that makes it like really easy to have similar environments from production to staging to dev, and benefit from like very advanced features like copy on write, where you get instant copies of the data, and anonymization, which make it really easy for developers to work with data without having to wait for jobs or static exports. So 3 scenarios: container logic, Terraform, or serverless database in Bunnyshell. Back to you, Amin.
Amazing. Well, thank you, Alex. I have another question. I believe this one's for Zeta. So do you have to run staging on Zeta, or could it be on AWS, GCP, Azure, or as well, or BYOC, which I believe is bring your own cloud?
Yes, definitely. So we do support bring your own cloud, which means that we run basically all this part here, which is like in this demo we just used our platform, but it could also be all in your own AWS account or GCP account or what have you. We would need the way we do it is that we split the control plane from the data plane, and the control plane we still run in our account, but the actual instance, the actual Postgres instances, all the data plane runs in your account, which also means you pay infrastructure costs directly to AWS or GCP or what have you.
So let's say
Thank
that
you.
this is similar to how Bunnyshell handles infrastructure. So customers of Bunnyshell bring their own cloud. There's also the option to use Bunnyshell provisioned infrastructure, but generally people want to bring their own cloud, connect their own Kubernetes clusters, and Bunnyshell makes use of that, and some control plane runs within Bunnyshell.
Thank you, guys. One last question I'm going to take. Can Bunnyshell integrate our existing CI/CD pipeline for ephemeral environments? Let me take this one if you're okay with that, Alex.
Sure, go ahead.
Basically, you can integrate Bunnyshell to your CI/CD pipeline using 3 different methodologies. So one of them is if you are a Git based operations, your operations heavily rely on GitHub Actions, you can integrate Bunnyshell through GitHub Actions. The second one is you can leverage the CLI. We do have a CLI that you can leverage in any CI tool that you might have, whether it's Jenkins or any other. The third way is to do it the old way, just API calls that you can integrate into your code immediately if needed. So these are the 3 ways that you can